Hello and welcome to More Interesting Maths. I'm David Myers with UTC South Durham. In this series we are looking at GCSE mathematics. This is for those of you that want to revise for your summer exams, catch up on any materials that you may have missed, or if you're a parent that's wanting to help your kids out at home. Generic introduction clip over, now let's do some maths. So, in our last lesson, we looked at expanding multiple brackets. We, before that, looked at expanding brackets. Now we want to see if we can go the other way. Almost everything in mathematics has its polar opposite. We have plussing and minusing, multiplying and dividing. We've even got squaring and square rooting. So it's no surprise that when we expand brackets, we want to know if we can factorise them as well. Can we get from some huge expression into what are known as the base components? Or pick any other word that you want, really. It all works. Factorising isn't actually as tricky as it sounds. It's not as new as it sounds anyway. It's something that you're already used to. A factor of a number is something that we can divide the original by without a remainder. So say, for instance, we can divide 8 by 8. We can also divide it by 1. We know we can also divide it by 2 and 4. 8 divided by any of those numbers will give us a whole number without a remainder. In a similar way, we can look at factors of algebraic terms. So 2x, well, if we just thought about the number 2, we can divide that by 1 and 2. So 2 and 1 must be a factor of 2x. We can also divide it by x and 2x. So 1 times 2x would give us 2x, and 2 times x would give us 2x. So all of these are factors of 2x. In a similar way, for 2x squared, there's not actually that many other factors that we need to add. Why is that? Because x squared, there's just another x in there. So all of these must be factors, plus a few extra. You could divide 2x squared by 1 and you get 2x squared. You could divide 2x squared by x and you would simply get 2x. So there are only 2 extra factors in 2x squared. Why is that really handy? Because we might look at loads of different forms of factorisation. When you get to your A-levels, for anyone who really wants to do A-level mathematics or beyond, we can turn this really complicated looking piece of algebra into its components. And that makes it a lot easier to analyse for reasons that you'll see. But factorising in the algebraic sense is to turn an expression into a product, the multiple of its factors. So when we multiply these two, which you'll have seen when we expanded brackets, we would get back to this lovely equation. The question is, how do we do that? In today's video, we're generally going to be looking at the Year 8 and Year 9 level of factorisation. Having a look at 2x plus 4. The question is, what can we divide both of them by? That's what we mean when we say we're looking for the common factor. Now, we can't divide both of these terms by x quite clearly. What we can do is look at both of the numbers, 2 and 4. And it seems fairly clear, at least I hope it does, that both of those are even numbers, so we can divide them by 2. So if we were to divide both of these by 2, we would be left with 2x divided by 2, 1x, and 4 divided by 2, which is 2. So we would be left with 2 lots of x plus 2. We've pulled out the common factor. Can we do this with anything a little bit more fancy? What can we see in both of these terms? Well, there's clearly an x in both of them. And then looking at the numbers, 3 and 9, well, they're both in the 3 times table. We can pull out 3, we can pull out an x. Altogether then, we can pull out 3x. We've just factored that out. So looking at this, what would I multiply? I'll put in some pen detail here just to make it a little bit easier. The question we need to ask ourselves is, what would I multiply 3x by, first off to get 3x squared. If my pen wanted to play ball, that'd make life a lot easier. There we go. So if I wanted to multiply 3x, what would I multiply it by first to get 3x squared? 3x times x would give us 3x squared. And then this 9x, what would I multiply 3x by to get 9x? Well, that would be a 3. So in order to fully factorise it, what we are left with is 3x times x plus 3. What about in this first question? X, y plus x. There's clearly an x in both of them, so that becomes the factor. X times y would give us xy. X times 1 would give us the x, so this factorised would be x times y plus 1. What about 2xy plus 4x? I'm going to show you my personal favourite method for doing this. A lot of you will be very familiar with it. It's certainly something that you might have seen before, or it'll look very similar to what you've seen before. We know that we want to get 2xy as our result, plus 4x as our result, sorry. We know that something has been multiplied, so we're reversing the grid method here. This is one of the reasons I really like it. We can reverse the grid method to get what we're after. First off, we need to find the common factor as far as we can see. There's a 2 and a 4 there. We know both of those will be multiplied by 2. Oh, sorry, they can be they are multiples of 2, as well as the x. So we can say that the common factor in both is 2x. And now we can break down everything we've been thinking about. If it didn't make sense to you up until now, it certainly will. Because we can start to think, what do I multiply 2x by to get 2xy? Well, the only thing missing is the y. What do I multiply 2x by to get 4x? That would be a 2. And right there, we have our other factor. And there's no doubt, at least there's no doubt in my mind, that when we factorise this, we get 2x times y plus 2. I'll show you that that does work for the technique we had above. That was what I was wanting to build to. You can see the answer here, so you'll be able to see how we pull it together. We know that the answer, or the thing we want to factorise, so thinking about it in reverse, is xy plus x. In both of them, we can see the x, so we know that that is the common factor. Finally, we start to say, right, x times by what would give me xy, that's just a y. X times by what would give me x, and that's 1. X is one factor, y plus 1 is the second factor. Let's try something slightly different, shall we? I believe if we jump over, we can do the factor challenge, as always. Let's pick one of the more challenging ones. So we'll skip through both of these. We'll look at 10xyz minus 15x squared y. We'll make something a little bit trickier for ourselves. So let's have 10xyz. Trying to write this as thick as I can so that you can see it on your screen. Minus 15x squared y. So we're going to pull out the first factor, the one that might be slightly easier to find. We'll pull out the second factor. 10 and 15, we can divide both of those by 5. There's an x squared here, but there's only an x in there. I apologise, it wasn't as obvious. So the lowest value of x that we can see in both of them is an x. There's a y in both of them, and there's only a z on the left-hand side, so we can't pull z out of both of them. Notice I didn't pull out x squared, because that would have been too much from this first term. We can pull out an x squared from the second term, but not from the first. So 5xy is the common factor of both. And then up here we can say, right, well, I know that 5 times 2 would give me 10. I've already got my x accounted for. I've already got my y accounted for. I don't have a z. There's a minus sign in the middle, so we'll keep that. 5 times by what would give me 15? That's 3. X times by another x would give us the x squared. And y we've already got, so we don't need to worry about that. Which means that in its factorised form, we should be looking at 5xy times 2z minus 3x. Right there. Have a go at this last one for yourself. See if you can do it. See if this method helps you out. But if I trust that you've paused it, then again we'll just rewrite the answer. X, y, z minus 2x squared y z squared. This is just designed to look evil, but it's perfectly doable. Plus x squared y squared. It looks awful, but in fact it actually makes life a lot easier for us. The answer is going to be a bit easier to extrapolate because the more terms you have, the fewer factors there are likely to be. Let's have a look at that. We've got an x in there, we've got an x in there, x squared, sorry, and an x squared in there. But because there's only x to the power of 1 in here, that means there can only be an x at the start. Is there a y in all of them? There's a y there, there's a y there, and there's a y there. Well, there's a y squared there, but again, that's too high a power to pull it all out in one shot. And is there a z in all of them? No. Because there's no z in this last term, which means that z isn't a common factor. So we can only pull out xy. So xy times what would give me xyz? Well, that's got to be a z. Minus, there were no numbers, so the 2 is going to remain where it was. We had an x, we need to get an x squared, so there's another factor of x to pull out. Y's been taken care of already, and z squared needs to remain. Plus, we need to get from xy to x squared y squared, which means in both cases we need an x and a y. So there is our second factor. This therefore becomes xy times literally everything else that we had on top. Try it for yourself. I don't know how you feel about it. What I will do again, actually I'm going to play it slightly differently in this case. What I will do is I'll pause, I'll reveal the first half of the question. So I'll go from questions 1 through to question 6. Then, after a little bit of time, I'll reveal the second half of the questions. By all means, have a go for yourself. Absolutely amazing work for those of you that got that sorted. If you're happy with that, then we'll move on to the second part of the lesson in this slides. If you're unhappy with it, drop back, have another look at the video explanation, see if you can figure out how to get the key themes. What about in exercise 2? Why don't we have a try with something like that? I'll go through question 1 with you to show you why I'm really happy with the technique that I've set you. If you have a different way of doing it, or if you have a different idea, by all means, share it with your friends and see if it works. Why not? But for question 1, we have 5x to the power of 5y minus 10xy. So the technique I showed you originally might have seemed a bit complicated, but one of the reasons I like it is it more or less always works, certainly with linear factorisation. Quadratic factorisation, which we come to later, is a little bit different. But our answer, or the answer we would get from expanding 2 terms, would be 5x to the power of 5y minus 10xy. What can we see in both of them? A factor of 5. We can see a factor of x in both of them, and we can see a y in both of them. So, for the first term, 5's been taken care of. X times something would give us x to the power of 5. Well, we've got 5x's being multiplied in there, and we've only accounted for one of them, so we would need x to the power of 4 to complete the set. Y's already been taken care of. Minus, sign in the middle, same sign, so we're happy with that. 5 times by 2 would give us 10. X has been taken care of, y has been taken care of, which means when we factorise this, it is 5xy from the left times x to the power of 4 minus 2. And if I reveal that, exactly what we were looking for. I apologise, it's just dawned on me that my webcam is sat over half of my working out. I'm hoping you accept that just around here, just underneath that, there is a 2. My apologies for that. I'm going to keep it in just because I'm a Muppet and we might as well let the world see that I am a Muppet, but there we are. Have a go at the others for yourself. I'll reveal all of those. As for the tough question, again, let me know in the comments if you want a different video on it. I will reveal the answers, but if you're genuinely interested and you want to know how to look into these type of questions, by all means go for it. That should give you a good amount to think of. I would say that the last question, for anyone who's very, very good, it would probably take you about 20 minutes to figure out what's going on. So if you're not feeling confident, don't worry that it's taking you a while. Just explore it. Absolutely well done if you've got all of that spot on. If you've made a few errors, don't worry about it. Double check. I would say mark each little bit. Did you get the factors right? If you've just managed to factorise, or find the common factor. You're doing well. Have another look back and see where things are. There could be a couple of problems with laws of indices. There could be a bit of issue with dividing. Please don't panic if it's all out there, if you think you've got it all wrong. Chances are you haven't got it all wrong. You've made one little error. So don't worry about that. See if you can spot what the common tricks are. Otherwise, if you're still with me, very well done. Let's skip on to the final part of this lesson series. And that is dealing with fractions. Me personally, I don't think that's too tricky, he says, because there is a really nice way of dealing with it. Let's have a look at, say, for instance, this half x plus quarter x squared. The first thing that I would suggest is, as you're probably used to with adding and subtracting fractions, make the denominators the same. So let's rewrite this question here with the same denominator. We can't turn this quarter into a half because we'd have to make the numerator smaller, and we don't want a numerator smaller than 1. We can turn a half into a certain number of quarters. We can times the top and bottom by 2 to turn this into 2 quarters. What does that mean we're looking at? It means that we are looking at 2 quarters of x plus 1 quarter of x squared. And in the same way we saw before, it now seems a little bit more obvious that a quarter is a factor of both of them. And I've just realised that I've covered the screen again. I'm just going to rewrite that, so apologies for that. Down here, 2 quarters of x plus 1 quarter of x squared. Yeah, and it turns up under the camera. Marvellous. So, we can factor out a quarter from both, and as always we can factor out an x. Not as always, but in this case we can factor out an x. A quarter times what would give me 2 quarters? Well, 2. X has been taken care of. Quarter's been taken care of. We have 1x, we need 2 x's, which means that we are looking at 2 plus x. If you're not entirely sold on why that works, I will show you the second example down here. Actually, yeah, I'll show you the second example as well. 3/8 of x plus 1 quarter of x cubed. 3/8 of x plus a quarter. Now, we can turn a quarter into something over 8. That would be 2 quarters of x squared. So we can see, sorry, that should be 2/8 of x squared. My bad. One of those days. It's fairly obvious that we can factor out 1/8 from both of them, as well as the x. So, I need to times 1/8 by 3 to get 3/8, and the x has already been accounted for. We have 2/8 over here, so I would have to multiply that by 2, as well as the x that would give us x squared. So looking at the answers for the first two, as promised, we've turned this into 2 quarters to get us a quarter of x times 2 plus x, and 1/8 of x times 3 plus 2x squared, because I didn't read the question. I spend my entire life telling people to read the questions, and there you go, folks. Not quite live on YouTube, but still being broadcast out to you to prove that teachers can make mistakes. I completely misread the fact that there was an x cubed in there. Oh well, easily fixed. Check your error, see where it comes from. Notice that I can do it as well, like the best of you. It's just one rookie error that is easily enough fixed. Let's see if I can do this one in my head without making myself look like too much more of a muppet than I already have. In a half and a third, we could rewrite those as something over 6. I'm not going to try and do it in my head and show off. We can rewrite this half as something over 6, and we can rewrite this third as something over 6. Why? Because 2 and 3 both go into 6. Times in this one by 3, this would become 3/6. And timesing this by 2, we would get 2 over 6. Which means we can now factor 6 out of both of them, so this will be 1/6. We can also factor an x out to give us 1/6 of x. So the y would still remain with the 3 from here, and the 2 would remain on its own because we've factored out a 6th and x. The last one, a little bit trickier, but again, that 2 can be written as something over 3, because a whole is just 3/3. So 2 must be the same as 6 over 3. We can now factor out the x squared. X squared remains to haunt me, as well as the third. So we are factoring out 1/3 of x squared. Oh no, I'm not the one in error. I'm not the one in error this time. This should... See, this time I'm convinced. This time I'm convinced that I've got this one correct. 6/3 of x squared and 1/3 of x cubed. The highest power in here is in fact x squared, which means we can pull out 1/3 of x squared from both of them, meaning that left over in here we will just have the 6th. Why? I took care of the third and I took care of the x squared. From here we've taken care of the third, and pulling this out, x squared to get to x cubed, there is another factor of x, which means in fact we are looking at 1/3 of x squared times 6 plus x. Okay, so in the scores of stupid mistakes, ignoring the technical faults, I'm not including the webcam fault in there. That was just a technical issue. I lost to Dr. Frost in the second question. No, I lost in the... Yeah, I did. No, I lost in the second question. Dr. Frost lost to me in the fourth one. So that's 1-0 in terms of daft mistakes on these YouTube channels. Okay, excitement over, 1-1. We'll see how that score goes. I'm going to keep a running tally of that. Test your understanding. I'm going to do all the working out for this as well. I'm assuming you've paused at some point while I've been rambling over. We'll see. We'll see how that carries over. So, back to the pen. Right. I hope I don't fall at the first hurdle with this one. We can pull out a half from both of them and an x squared. So the common factor is going to be a half of x squared. I argue, therefore, that what is remaining, because we've pulled out a half of x squared, that's only going to be a 1 plus 3x in the answer. So we should be getting an answer of half x squared all multiplied by 1 plus 3x. There we go. There we go. We're in agreement on that one. Score stays the same for all of us. In the second example, we need to turn them into something over 12. Where did I get that something over 12 from? It's because 3 times 4 would give us 12, and there's no lower factor that they'll go into. So this, therefore, becomes 4 over 12. This one here would become 3 over 12. So we can pull out a factor of a 12th. I can see in both of them, there's only an x in one of them, but there is a y in both of them. Which means what's remaining over, we have 4 12ths over here, so I'd have to multiply the first term by 4. And there's also that x that didn't appear in the second term. We have the 3 from up here that we haven't factored in yet, as well as, there's no x's to worry about, but there is y times another y to give us a y squared. I argue that the answer for the last one, therefore, should be 1/12 of y times 4x plus 3y. Good, we're in agreement. We're happy. We're doing well so far. And finally, for the last one on Test Your Understanding. Whew, no pressure. This we can rewrite as 9 divided by 3. Why? Because it now makes the denominators the same, and 9 divided by 3 gives us 3 that we had before. Which means we should be able to factor out a third of something. I can see an x in both of them. I can't see a y in both of them, so that's it. First factor taken care of. We have to multiply this by 9 to get the 9/3. There's an x taken care of, but a y has not been taken care of. Plus, the numerator up here is a 2. Third's been taken care of. X has been taken care of. I argue that that is it. So, revealing the mouse, moment of truth. Yay, we're in agreement. Perfect. Good. So, between me and Frosty, we've made one mistake each, and we're absolutely sorted for now. So what I will do is shift you on to the final exercise. These I will reveal odds and evens in one way, shape or form. Have a go for yourself. And that wraps it up for today. Very, very well done. If you've got it at home, If you've made a mistake, what we've now learned is that you're just like the teachers. You're like the teacher that wrote these slides with one tiny little error, and you're like the teacher that delivered it, that didn't check it, and made the same errors in his own working out. I make mistakes, you make mistakes, we all do. If you have made a mistake, don't worry about it, laugh it off, figure out where it came from. That's, for me, half the fun of doing maths in the first place anyway. We make little rookie errors, we realise where things haven't quite knitted up properly in our heads, and I think it's a real joy to be able to undo that. But I'm a massive nerd and I'm never going to apologise for that. So, if you have been able to make a mistake and laugh it off and move on and develop your own learning that way, then know that I'm really proud of you from way over here, and you should be damn proud of yourself as well. Very well done, folks. And that is it for this video, ladies and gentlemen. Thank you so much for watching. If you think it helped you out with your maths revision at home, then please click subscribe to get notifications on future videos. Share it with a friend if you think it will help them as well. There is a PayPal account, but please don't feel obligated to do that. 10 or 12 pence if you think that it's worth it for you at home and you liked the video and the content that I've put out. Failing that, thank you so much to Dr. Frost Maths for the slides, for UTC South Durham for inspiring these videos, and most importantly to you at home for watching. I'm David Myers. Take care.